In this video, we are going to learn how to perform simple linear regression in Excel. So, I'll take an example to demonstrate how to perform simple linear regression in Excel. So, I've got a data. So the data looks like this. I've got data for different employees. Okay, so I've got data for 21 different employees in a company whose salary and experience is available to us. So we want to know that how is salary of an employee related to his experience, or how is experience of an employee affects his salary, right? So that is the objective of the analysis. All right. So I've got salary column here, salary data here, and then the corresponding experience for the employees. Now we want to run a regression between salary and experience, which will explain how is experience affecting salary of an employee. Okay, so salary we're calling it as dependent variable, and experience we're calling it as independent variable. Why so? Because finally we will want salary is depending on experience, or salary is a function of experience. So salary technically is known as dependent variable, and experience is known as independent variable or explanatory variable. Okay, so in Excel it's known as y variable, so we'll call it y variable, and we'll also call this x variable. Okay, so that's how Excel recognizes this. Okay, x means independent, y means the dependent variable. Okay, so how do we perform regression? Okay, for that you need to go to this place, data analysis. So you need to first get this add-on in the Excel sheet. Okay, so the data analysis tool pack should be there in Excel sheet, and many times you won't find that at this place. So what you need to do in that case is go to file, and then go to option, uh, and then click on add-ins, then go, and then it's already added in my Excel sheet. Otherwise, just check in this box, and then checking the last box if you want a solver, and then press OK. It's going to come over on the front page. Okay, so I have already done that, so you can you can actually do that if it's not available already on the front page. Okay, on the data page. Okay, so this section you will get it. Okay, this is data, and you have this data analysis. Okay, when I click this, there are number of analysis tools available on Excel. So I'll directly go to the regression. So here is regression. Okay, so I click on this. Okay, all right. Now it asks me to give the input y range and input x range. Remember, input y means the dependent variable range, and input x means the independent variable range. We have got only one independent variable in this case, right? So by definition, if there is only one independent variable in your regression, we call that as simple linear regression. And I repeat, it's known as simple linear regression when there is only one independent variable. All right. Okay, so we'll first select the dependent variable, which is salary, right? So I select the dependent variable, fine, which is the input y range. Then I select the input x range. So I then select experience, which is the independent variable, right? And we have only one independent variable. In fact, you can use more number of variables, but we are only demonstrating a single variable regression, a simple linear regression. So we will not use more than one independent variables. Okay. Now there are so many options available to you. Okay, you can define your confidence interval. Okay, normally the confidence interval is taken as 95%. Okay, so we'll use that as a default, but you can actually make even more stricter, like you can make it 99% as well, but we'll stick to 95%. Okay, which is commonly used confidence level in regression. We also want our output range somewhere, right? So what does that mean? Output range is that when you build a regression model, it will also use the regression equation to give you the predicted value of your dependent variable, or the predicted value of salary. Okay, salary is our dependent variable, right? So we have these actual values here. So we also want the predicted value. Since this is a predictive model, you will always have the predicted value, right, from the regression equations. So we also want that somewhere here. So what we'll do is, okay, so I choose this place and then I'll select this place where I'll have the predicted value. So we'll also get the predicted values somewhere here. Okay, other than that, there are options like where do you want the regression results to be printed out. You can, choose new sheet or new workbook, but I'll have it over here only. Okay, I'll have it on the same Excel sheet, so I am not going to choose that. I also want the residuals. Uh, I want the residual plots, the standardized residuals, the line plot as well, and I don't want the normal probability plots because we are ignoring the normality assumption for the moment here. Okay, which is, you can also check in. It entirely depends on you whether you're strict about normality assumption or you're not so strict about it. So I'm not so strict about it because it's a small data set. I'm not going to, I know that it's going to be violated most probably, so I'm not going to worry about the normal probability plots here. Okay, so all that, once it's ready, just, press OK and you have the result in front of you. Now you can see your result. Okay, so first you'll, in any other software where you are performing regressions, Excel will give you the summary of the summary statistics of the regression output. So we have got the multiple R, the R square, adjusted R square, and so on. So there are 21 observations in all, and then multiple R is nothing but the actual correlation between dependent and the independent variable. Okay, and R square is nothing but R square actually explains that what is the percentage of variation in dependent variable which is being explained clearly by the independent variable. So 66% of variation in salary is being correctly explained by the variable Excel, right? And then adjusted R square is is a more accurate R square, which penalizes you for use of more number of independent variables. Since we don't have many independent variable, we just have one independent variable, so we need not worry about adjusted R square. So the most important statistics in this case is R square. So R square lies between 0 to 1. Okay, and the more closer it is towards 1, it is the better it is for us. Okay, or the more efficient the model is. Okay, so if it is very high, then it's a really good regression, or it has come out really good. Okay, and you can also take a look at the ANOVA, which will give you the degree of freedom, the sum of square, and the overall significance level. So what is so important for us is the overall significance level in this particular chart. So overall significance level should be less than 0.05 for a model to be modeled to be a good model. Okay, and we can see that it's less than 0.05, or we always want that to be very close to 0, right, which will give us a confidence that the model specification is actually good. Okay, or the model is actually good one, it's actually a linear fit or a straight line fit. Okay, so it that's what it says. The most important part of regression analysis is understanding the coefficient of regressions, and you have so many values over here, and we'll go through one by one. So in any regression, if you know regression theory, you will always have an intercept and then slope coefficient, right? So intercept is 5, 30, 0.95 as you can see on the screen, and the slope coefficient for the variable experience. So x variable is your experience, so we can write it as experience here. Okay, so the slope coefficient against experience is 742.61. Since it's a linear equation, we can actually write it like this: salary is equal to 530, which is the intercept, and then the slope coefficient is 742 0.69, right? 0.69 1 multiplied to experience. So this is the final regression equation, which is simply a linear equation, right? Now you can put the value of experience and you can find out salary. If a completely new employee comes to you and he says he provides his experience level, you can actually predict his salary level, right, by using this equation. So this is the regression equation estimated by the algorithm. Okay. Now, there are few more important statistics that one should look at while doing regression. So here are some of the important statistics. There is standard error. Okay, so standard error is more like a standard deviation of the coefficients. Okay, and it should be less, right? The lesser it is, the less it is, the better the model is. Okay, so you should always ensure that the standard error is quite low. If it is increasing, then it's not a good sign. And then we look at the t statistics. Okay, so t statistics will tell us the significance level of the the estimates. Okay, so estimates are the coefficients. Okay, so significance level, that means whether they are different than 0 or not. Okay, and we can also get to know that by looking at the p statistics. Okay, so which is same. Okay, p statistic is another version of t statistics. By looking at the p value also, you can actually talk about the significance level of the coefficients. Now you should ensure that the p value should be less than 0.05 for the 95% confidence level that the coefficients are significant. Significant means it's actually greater than 0. It is having significant impact, or we can keep it in the model, right? So the p value should be less than 0.05. Okay, so it is actually 0.05 for the slope coefficient, but it's not actually 0.05 less than 0.05 for the intercept. Okay, and then we'll also have the lower confidence level and upper confidence level for the estimates, which is not very important for now. So all that is important for us is the coefficient and the p values, just to look at whether it's significant or not. We'll also have the residuals and the predicted values. So we have got these 21 observations for 21 employees, and we have the predicted values for the 21 employees. Predicted value of y, which is predicted salary. Now you can actually compare the predicted salary from the regression equation. So what is the regression equation? This is the regression equation. Okay, by using the regression equation, we have been able to get the predicted values. Now if you look at the predicted value of the actual value of salary for the first employee, that is 3000, right? Whereas the predicted value of the first predicted value of salary for the first employee is 3501, right? So that is that the error is 501, right? Now let's go to the second employee. The actual salary is 2000, whereas the regression equation predicts that his salary is 2016, which is pretty close. So that's a good prediction. So you will see the residuals, which is the difference between predicted and the actual, or the actual minus predicted. So your error is equal to the actual minus predicted, right? And you should ensure that a good model should give not very high residuals, right? But there are few cases where you will always get high residuals, because the model will not be able to predict all the values or all the salary for all the employees accurately. It is going to do a good job in many cases and bad job in many cases. Like in the first case, it's a bad job. In the next case, it's fairly good. Then again, it's bad. It's bad again bad. Then it's fairly good, okay, and again a problem. So there will be error, there will be issues, there will be cases where the model is not able to predict the actual salary properly. But there should be few number of cases, should not be just too many cases, otherwise there's something wrong with the model. One thing that you should check is that you should ensure that the residual sum should be close to 0 or exactly 0. Now if you look at the residual sum, you can see on the Excel sheet it gives me the sum. So 2.7 to the power 10 to the power minus 12, which is very close to 0, right? So that's the assumption here, is that the sum of error, the sum of the residual should be 0, which is an assumption in linear regression, right? And you also have the standard residual. So what does standard residuals mean? Well, standard residuals are coming from the standardized variables. So standardized variables means we simply if x is a variable, its standard variable is nothing but x minus the mean of x divided by the standard deviation of x. Okay, many times this is a requirement, okay, that we always convert or transform the dependent and independent variable to standard variables and then do the regressions. So if that is what you need, many times people need it, okay, and then you will always get the standard residuals as well, okay, but the regression line remains same irrespective of whether you want to use the raw data, okay, or non-transparent variable or a standardized variable. It doesn't matter, the regression line remains same, except there will be slight changes with the residual values. Okay, let's look at the plots. We have asked for two types of plots. Okay, the first one we'll see is the residual plot. Now in regression, the residual should be non-correlated, that's the first thing, and then they should be lying close to 0, second thing, and then there should not be any pattern in the residuals. Okay, now you can see that the residuals are around this x-axis, right? They're very close to the x-axis and very close to 0. That means y is 0. That means and they should be spread across upper side of the x-axis and lower side of the x-axis, and you will see there are plenty of residuals in the upper side of the x-axis, and there are plenty of them in the lower side, right? That means they should cancel each other so that the residual sum should be 0, right? And then you'll also see that there are some of them which are having very high residual, so these are the outliers, okay, or these are the extreme points. In regression, normally we avoid these extreme points and outliers so that our regression equation will be better, or will be able to generalize the pattern in the data in a better way, right? So you can actually take away this data point sometimes, right? But if it is not a very big problem, you better keep it in the regression without because that's always good information, so you should not remove them. So if it is seriously causing issue, there are too many outliers or extreme values, then it's actually a problem and you should remove some of them. The next plot is the regression plot, where there is a plot between the actual values and the predicted value with respect to the x variable. Now you can see the actual and the predicted value. Okay, if I make it a little large, it will be better. All right. So the red one is the predicted value of y, so predicted salary, and the green one or the blue one is the actual salary Okay. Now you see that the predicted salary is actually passing through the the actual values, right? Hence, it is actually passing through the middle of the actual value. So, and that's what we want in a regression line. That the regression line should be passing through the middle of the data points, and that's what we are seeing here. So that's all about how you perform a simple linear regression um, in Excel. You can actually extend this to multiple linear regression as well, where you can use more than one independent variable, where you'll be little more concerned about various other things. So we'll see that in another video, another tutorial. So please subscribe to our channel for more videos, and go to our website for all our tutorials.